Hello everyone, nice to see you again. Today we're gonna see or we're gonna visualize your data. So I have ready to go the coding for the R Studio today. So you'll make a little faster this video and you might have to go back to follow it, or also you can follow it with these codes on your computer as well. So you're gonna be able to do that, and then you can check everything. So first thing I have here on top of the page of some packages that I wanted to install. And after that, I have all the data that I want to import in here. So some things on the data import. So I have basically the raw data here. This is data from the carcass composition estimation. So from the DEXA machine. And you can see that I processed this data here, and I have data 1 and 2, which is basically experiment 1 in data 1 and experiment 2 in data 2. And the way I did it, I select by study number on the first example here, and the second one I select by treatment number. So treatment number 1 to 12 would be the experiment 1, and the study number 1 is also experiment 1, while study number 2 would be the same treatments I selected here. So there's different ways you can do the same selection in this case. All right, so let's start visualizing the percentage of lean from the whole data that we have. Okay, so basically here I have an histogram, and the histogram show all the frequency, so the number of the data that you have observed in here, and then the distribution. So to look at the distribution that you usually want to see in histogram, it would be more or less a bell shape. This one, if you see, it doesn't have a perfect bell shape, but it seems pretty normal. You can see that it's a little bit skewed to our left, but overall I wouldn't say it's too bad. Most of the data that you're gonna have, they're gonna be normal, but still it's nice to graph them and see how they look like, because in any case that you might have any observation that is an outlier, or also you might see some pattern that is not correct, and that's something that you don't want to see in your data, so you're able to select exactly or specifically the data that you need for your analysis. And then when we do for, let's say, experiment 1 here, you see there's a little bit of a difference on the previous plot already. So of course you see the numbers, so the frequency decreases, of course, because we have only one experiment here. But also this data seem a little less skewed, or let's say still looking good for a normal distributed data. And the last one, let's do for experiment 2. And again, you see experiment 2 might have some differences in this skewed as well as comparing to the total. So let's look at the plot in a different way. So it's still having the same histogram plot, but in this case, I have our factor for experiment 1, our I2, separated by different colors. So now we actually can identify some of the treatments differences too, at least some of the patterns on these treatments here. And you can do the same for our experiment 2. So you also can see some of the patterns on related to that. So for the second data set I imported, it was body weight of the birds. And when I plot the body weight in Instagram, you can see that there's a huge difference in body weights here. So you're starting from 0. So this is a body weight in grams, going all the way up to 5 kilograms. So there must be one problem here, that you definitely have different ages of birds in here. So let's have a look when we fill by treatment too, and you can definitely see some differences by treatments as well. So let's just select some specific age. So with the new data set I've coded here, I basically gonna select the week 15 only, and only the study one. So let's run this new data set here. So create a new data set, and let's run the histogram. And now you see that from week, being very specific, from week 15, you can see that the data more or less look like normal. And in this case here, if you actually plot it by treatment, you would see there's a difference in treatment as well for this case here. So if you plot individually by treatment, you would see the exactly frequency per treatment, and that could give you a good idea for if you have any outlier or any trend on your analysis later. So for my last data set I have, I also brought some score data, so back fatter score. So I'm gonna run that. So I just had an error here when I was running that. It says that I have my variable, my x variable, or in this case, it would be my response variable. It must be numeric. So probably when I imported this, it imported as a character from the CSV file. So this is a CSV file. I did have some coding here to change that. So I'm just gonna run this. I'm not gonna explain go a lot into details, but if you need to change the your variable from character to numerical, and I've done that, and now I just changed the name. So let's plot this specific backfatter score. So because we have scores in here, you see that the numbers they're not, or they might not be specifically on the on the number that they are, but when you look at the data, you'll see that they're just so those are integer numbers, and so it basically would be only 0, 1, 2, 3, and 4. So this was a 5 scale score. And generally, this data would be submitted to analysis that is not a parametrical analysis. And even though it looks normal distributed from the graph, well, there's different opinions on that, but this data could be analyzed in a different way. But for our purposes, for this specific class, it's not a stats class. So you're going to be analyzing if you have a score or a skill with scores as your data. You're going to be doing a normal uh, analysis of variance in this case for this data. And if you plot, just as the examples above, in this case you add different treatments, you can actually see I have a treatment 99 in here. This treatment was the meals. So basically I have we identify the meals in our trial as treatment 99. And we probably have some missing treatments here, so that's why we have NA in this case here. Okay, so let's see one box plot as well. So this box plot was made from the trial, the first experiment. So you can see the identification here. And basically you can see here the You can see the data plotted as a box plot. A little bit of a box plot graphs. So 50% of your data will be on the main square right here. Let me actually give a little bit of a zoom in this. 50% of your data, while 25% will be on top, and 25% will be under here. So basically, we call the quartiles in this box plot. And here, in this case, we have the median. There are some box plots that are going to show you the median and the average too, but for specifically this one has the median here. So you can actually have a look for all different ones, and you can actually see a trend in this percentage of lean. So you can see that it increases from treatment 1 to 6, and then again goes down, but it seems to increase in that direction. And I'm not going to show you why, but you probably will find that out if you have this. I'm not sure if anyone has the lean as their response variable, but you see that on body fat. And you can do a similar thing just to get your numbers, so you can actually see the numbers for each one of them. So you can see your minimum, your max, and the quartiles, as I mentioned, so you can see the median and the mean in this case here when you do a summary of the data. And the last one, I have a plot. Took a little while to run, but I had a plot of our data. So remember, this is our raw data for body weight, so all the data from all different ages. And remember, as I mentioned, we have the treatment 99. So this plot show every data point. So you can see a lot of data was collected and is between 0 to 5 kilograms. And again, you have the treatment description in here. So to be more specific with the data, so remember, I've run on top here for week 15 and the study number 1 only. We're going to run the plot for this right here. And now you can see on week 15 the average, basically the average body weight in this case here. I don't remember exactly if it was the average body weight. Maybe actually was the mean body weight because of the precision fitting system. We selected the median body weight, and in this case, the median body weight was chosen just to avoid having the body weights that are, or having on the average the body weights of birds that have gotten to the station with a pair, so 2 birds, and then in that case one RFID was red, but then the body weight collected was double of the bird, and that would, if you collect the mean, you'd have a little bit of a bias observation in that case. But you can see that our median body weight also follows a certain pattern at 15 weeks of age. So you can see that it decreases as the treatment increases until the 6, and then goes up again for treatment 7, and then it decreases again as it goes to the treatment 12. And this was basically because if you remember our body weight trajectories, and you can actually go back and check this to exactly what was the body weight trajectory on 15 weeks of age, and you're going to see that those birds, they are supposed to be in a higher body weight at this age compared to the birds that are in a lower body weight, and again for those treatments here. Okay, I think that's it what I have for this video, and see you in the next one.